Hey everyone, welcome back to another video. Today I wanted to talk about plotting points to make graphs of equations. So an equation in its simplest form is a statement. And what that means is, say if you have y equals 2, well that's a statement, right? It's true, y equals 2. There's nothing else that it can be, it's only 2. Similarly, you can have x equals 2, right? And that's another statement that's also true. Or you can have something that's a little bit more complex, which would be y equals 2x plus 1, right? Now, in order to find out whether this statement or equation is true, right, we'd have to see what x value and what y value satisfy this equation. And what I mean by that is, let's say y equals 2x plus 1, right? And let's say that we choose x to equal 2, right? Well, if we plug in that x value, we'll get 2 times 2 plus 1, and that's equal to 5, right? So we know that the point, right, that is 2 and 5 satisfy this equation because they make this statement true, right? Because the whole equation becomes a true statement. Now, if we say something like, let's just say y is equal to 6, right? Well, we can no longer say that the x value is going to be a 2, right? Because 2 won't give us a y value of 6 once we plug it into the equation. It'll give us a value of 5, right? So if we were to say, oh, is the point 2, 6 a valid point? No, it's not. Why? Because it doesn't satisfy the equation. It gives us a false statement. So when you graph an equation, what it basically consists of is all the points that satisfy the equation, right? So similarly, like the example above, right? A valid point would be 2 and 5. To find another point, we can just pick an arbitrary x value, right? Let's say x equals 4, right? And to find out what satisfies this, we'd simply plug it into the equation, and we'd have 2 times 4 plus 1 is equal to 9. So then we'd get another valid point where 4 and 9 are the x and y value. So you can keep on going with this, right? Pick arbitrary x values, right, until you get enough points to get a great picture or a graph, right, where you'll see the correlation or basically the description of what this equation looks like. Okay, so let's try a quick example. What we want to do is take an equation and find enough points to where we can graph those points to give us a accurate description of the graph. So let's go ahead and graph y equals 4x plus 2. Okay, so just like in the example above, what we'll go ahead and do is we'll just pick arbitrary x values, right? So let's go ahead and say x equals 1, x equals 2, x equals 3, x equals 4. Let's throw in some negative numbers in there. X equals -1, and x equals -3. Okay, so like we did above, all we're going to do is we're going to plug in these x values, right? So y equals 4 times 1 plus 2 is equal to 6. For the next one, 4 times 2 plus 2 is equal to 10. Equals 4 times 3 is equal plus 2 is equal to 14. And let me go ahead and pause this and fill all these out so that you guys don't have to watch me just write all of these out for you. Okay guys, so I'm back. So as you can see, I went ahead and finished calculating out all the y values that we needed. And as you can see in the far right column, I've gone ahead and written out our points, right? Which are consist of our x and our y values, right? So what we'll do now, since we have these points, now we could go on forever. We could go up to infinity and to negative infinity, right? And calculate all the points we wanted. But for the sake of the example, we only need a few points, because now what we're going to do is we're going to plot them. So as you can see, I've gone ahead and drawn out a graph or an x and y plane, and all we have to do now is take the points that we calculated, plot them on the graph, and then connect the dots, and we'll have an accurate description of our graph. So let me go ahead and do that, and I'll be right back. Okay guys, so I've gone ahead and plotted all the points, as you can see, and now, like I said before, this graph isn't to scale here, so the line might be a little bit off, but realistically what we would want would be basically a straight diagonal line, right? Now once we connect these, as you can see, that's what you would get, and that's an accurate description of our graph, right? Because all the points here satisfy the original equation because they make it a true statement. We can't have any points on there that make the statement false, because then they wouldn't be part of the graph. Well guys, this concludes this video. If you guys like this, if it helped you in any way, please hit that like button, share it with your friends, leave a comment down below, and I'll try to answer any questions you might have. Thanks again, and I'll catch you on the next one.